Hello everyone. On this video we will be looking at the derivatives of tangent, cotangent, secant, and cosecant. Alright, so starting off, we will look at the derivative of tangent x, which is secant squared of x, the derivative of cotangent of x, which is negative cosecant squared of x, the derivative of secant x equals secant x times tangent x, and the derivative of cosecant x equals negative cosecant x times cotangent x. Alright, so first thing we're going to do is prove our tangent. Excuse me. Okay, so prove of the derivative of tangent x is equal to secant squared x. Alright, so first thing you have to do is remember that tangent is equal to sine over cosine. Alright, so that means the derivative tangent x can equal the derivative of sine of x over cosine of x. Okay, and from there we just apply the quotient rule. Okay, which means you have your denominator. Let me move this over a little bit. That equals your denominator, which is cosine of x, times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. Alright, so we go ahead and simplify each of those terms. So you have cosine of x, and the derivative of sine is cosine, so that's times cosine of x, minus sine of x, times the derivative of cosine is negative sine, all over cosine of x squared. Okay, so you have that minus negative, that becomes positive. So you have cosine times cosine, which is cosine squared. So you have cosine squared of x, minus minus is plus. So sine times sine is sine squared. So sine squared of x, all over cosine x squared is the same as cosine squared of x. Okay, so if you remember from trig, cosine squared plus sine squared equals 1. Alright, so that means that leaves us with this whole thing just turned into 1 over cosine squared of x. Okay, now Now, if you remember also, 1 over cosine is equal to secant. So 1 over cosine squared is equal to, move that up, secant squared, which proves what we were looking for. All right. So if you are still writing, feel free to press pause. But now we're going to move on to our next page and prove secant. Oops. All right. So we have our proof of the derivative of secant x is equal to secant times tangent. Okay. Now, once again, you want to kind of remember something. So remember that secant is equal to 1 over cosine. All right, so just like with the tangent, the derivative of secant is equal to the derivative of 1 over cosine. Okay, just like I said, it's just like with tangent, you're going to use the quotient rule. All right. So that means using the quotient rule, you have your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. All right, so that means we have cosine times the derivative of 1. Okay, so you have cosine x times the derivative of a constant is just 0. Minus, you have 1 times the derivative of cosine, which is negative sine. So you have 1 times negative sine of x all over cosine x squared. Okay, so 0 times anything is just going to be 0, so that's going to disappear. Okay, so you have minus 1 times negative, so negative is positive. So that leaves you with sine of x over cosine x squared. We're just going to expand that to be cosine x times cosine x. So cosine x times cosine x. All right, so we can actually separate this to equal 1 over cosine x times sine of x over cosine x. Okay, so 1 over cosine is secant, and sine over cosine is tangent. Okay, which matches up with what we have here. All right, so now we're going to prove our tangent, well, cotangent. We already did tangent. So if you are still writing, feel free to press pause. We're going to go ahead and start on the next page. Okay, so now we have the proof that cotangent is equal to negative cosecant squared. All right, so to do that, you want to remember that cotangent is equal to cosine over sine. All right, so that means starting off, the derivative cotangent of x is the same as the derivative of cosine over sine. Okay, and once again, we're going to do like we did before and use the quotient rule. Okay, move that equal sign over a little bit. Okay, so we have our denominator, and let me give that a little more room. So we have our denominator times the derivative of our numerator minus the numerator times the derivative of our denominator all over your denominator squared. All right, so now let's go ahead and simplify that. So we have sine of x. Derivative of cosine is negative sine, so you have negative sine of x minus cosine of x times the derivative of sine is cosine all over your denominator squared. We'll just make that sine squared of x. Okay, so here you have negative sine squared minus cosine squared. Okay, so we're going to do here is we're going to factor out a negative 1 in our numerator. Okay, so if we factor out the negative 1 here, we have negative 1, so you have sine x times sine x, which is sine squared. If you factor out the negative 1 here, you have cosine and cosine, so that's plus cosine squared x all over sine squared x. Okay, so that gives us negative 1 sine squared plus cosine squared equals 1. So this just becomes 1 times 1 over sine squared. Okay, so if you remember, 1 over sine is equal to cosecant. So this gives you negative 1 times cosecant squared, which is just negative cosecant squared. Okay, which is exactly what we have up here. All right, so if you are still writing, feel free to press pause. But now we're going to prove the derivative of cosecant. Okay, so proof of the derivative of cosecant equals negative cosecant cotangent. Okay, now in this case, you want to remember that cosecant is equal to 1 over sine of x. Alright, so just like before, you know the quotient rule is going to come into play. So the derivative of cosecant is the same as the derivative of 1 over sine of x. Okay, once again, we're going to use the quotient rule. Alright, so that means you have your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. Alright. So here we know that the derivative of a constant is equal to 0. So this whole thing's disappeared because 0 times anything is just going to be 0. So you have 0 minus 1 times the derivative of sine is cosine of x all over the sine squared. Okay, so instead of sine squared, kind of clean that up a little bit. Instead of sine of x squared, we're just going to make that sine of x times sine of x. Okay, so if we separate this, that could be negative 1 over sine of x times cosine x over sine of x. Okay, negative 1 over sine, well, we already know that's cosecant, or negative cosecant in this case. And cosine over sine is cotangent, which matches up perfectly with what we have. Alright, so if you are still writing, feel free to press pause. So now we're going to go ahead and jump right into our examples. Okay, so let's say, for example, you want to find out what is the derivative of f of x equals negative 5 cosecant x minus 4 secant x. Alright, so to find that derivative, we know that our f prime of x is going to equal negative 5 times the derivative of cosecant minus 4 times the derivative of secant. Okay, so that means this is going to equal negative 5. Derivative of cosecant is negative cosecant cotangent minus 4 times the derivative of secant, which is secant times tangent. Okay, so that means your derivative, you have negative 5 times a negative, which is positive, so that gives you 5 cosecant cotangent minus 4 times secant. Let me clean that up a little bit. times tangent. Alright. Okay, so we still have plenty of room on this page, so we'll go ahead and do another example right below it. Okay, so if you want to find the derivative of f of x equals -2 cotangent x plus 3 cosecant x. Alright, so what I want you to do is go ahead and press pause and try to work this one out on your own. Alright, so I'm assuming you've pressed pause and you've worked this one out. So let's go ahead and verify your answer. Okay, so your derivative is equal to -2 times the derivative of cotangent plus 3 times the derivative of cosecant. Okay, so that ends up equaling -2 times the derivative of cotangent is negative cosecant squared plus 3 times the derivative of cosecant, which we know up here is negative cosecant times cotangent. Okay, so we can go ahead and simplify this. You have negative times negative, which is positive, so you have 2 cosecant squared, positive 3, since that's a negative, that's going to be minus 3 cosecant times cotangent. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Whoops. Alright. So for our next example, it's a little bit of a word problem. Okay, so what if we want to find the equation? Well, not really a word problem, but a little bit bigger than just finding the derivative. Find the equation of the tangent line to the graph f of x equals cotangent of x at x equals pi over 4. Okay, now the good thing about this is you don't have to actually draw out the graph. Okay, so a quick hint on this one. Use the point slope form. Y minus y1 equals m times x minus x1. Okay, that usually helps. Alright, so to solve this one, first thing you want to do is find your ordered pair. So you want to find your ordered pair x f of x. Well, in this case, your x1 and f of x1. So I'll put the 1 there. Kind of clean that. x1 f of x1, which is the same as your x1 y1. So to do that, we plug in our power over 4 to our function. Plug in x equals power over 4. So what that gives us is f of pi over 4, which is equal to cotangent of power over 4. Cotangent of power over 4 is just 1. So that means your x1, y1 is equal to pi over 4, 1. Okay, so that's your point, your x1, y1. Okay, next, you find your slope. So you find your slope at x equals pi over 4. All right. Sorry about that. Dropped my paper there. Okay, so to find your slope, that just really means to find your first derivative. So f prime of x is equal to negative cosecant squared. So at point pi over 4, excuse me for a little tongue tied there. F prime of pi over 4 is equal to negative cosecant squared pi over 4. Okay, which is equal to negative 2. F prime of pi over 4 is equal to negative 2. That's your slope. Okay, so if you're wondering how I got that, I'll go ahead and write that out for you. Okay, so we know that cosecant is equal to 1 over sine. Okay, so since sine of pi over 4 is equal to 1 over square root of 2, we know cosecant is just the reciprocal of that. So cosecant of pi over 4 equals square root of 2 over 1, or just square root of 2. So that means that cosecant squared pi over 4 is square root of 2 squared, which is just 2. And remember, that's a negative, so that would be negative 1 times cosecant squared of pi over 4. So that negative just follows right down. All right, so now we go ahead and we plug into our point slope form. Oh, forgot to close that up. There we go. All right, so next we have our y minus y1 equals your slope times x minus x1. Okay, so that plugging everything in we have y minus y1. Remember your y1 is 1, so y minus 1 equals your slope, so that's negative 2 times x minus x1, which is pi over 4. Alright, so we can go ahead and distribute that negative 2. So you have y minus 1 equals negative 2x plus 2 pi over 4 is just pi over 2 once you simplify it. So if we add 1 to both sides, we have y minus 1. Y equals negative 2x plus pi over 2 plus 1. Alright, so we go ahead and combine those two. You have y equals negative 2x plus pi over 2 plus 2 over 2. Okay, so we go ahead and simplify that. We end up with y equals negative 2x plus 2 plus pi over 2. As our equation of the tangent line at the point pi over 4, x equals pi over 4. Alright, so hopefully this video made sense, and I will see you on the next video.